Hey guys, so today we're going to be looking at ellipses and their properties. So I'm going to start out by writing the equation, which is this. Okay, and you might be wondering what is a squared, what is b squared, and what is b squared when they give it to you in the equation, okay? Because knowing the difference between a and b is important. So a is going to be whatever denominator is larger, okay? So if let's say the equation was y squared over sorry, let's say this one was something larger, so 4 equals 1, right? We would have to switch the order of these two, okay? Because this one is larger, okay? So it'd be y squared over 64 plus x squared over 64 plus y squared over 49 equals 1. And this is important because, or we'll see this right now actually. So going back to this standard form, okay? We have our, let's say this is our coordinate plane, okay? Then our ellipses looks like this, okay? There's a point here, 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 and here. Connect it like this, right? Okay, let's say that's our ellipse, right? So these two lines, or these two dots, sorry, are called foci, okay? And then this is called, so this length, right? That would be called the minor axis, okay? And then the longer one, or sorry, like this, right? That would be the major axis, okay? And minor axis is going to be whatever axis is, or whatever axis is smaller, right? So let's say our thing looked like this, okay? Then this would be the major axis and this would be the minor axis, right? So how we know which one is major and minor, we look at our equation, okay? So going back to here. So whichever one is bigger goes first, right? And let's say for whichever denominator is bigger, the numerator is x squared. So because the numerator is x squared, we know that the major axis will be on the x-axis, okay? Or let's say, let me write this other example, okay? So it was y squared over 36 plus x squared over 16 equals 1, okay? Then the major axis would be on the y-axis. That's how we know where it is, okay? And then now, another important part to know is how to find these dots, the foci, okay? And let's start out with our basic equation to know, or formula, whatever you want to call it. C squared equals a squared minus b squared, okay? So a squared minus b squared is, these values, right? So we can get c out of this, okay? And then the foci is equal to let me write it down, then I'll explain it. So this is how the foci is calculated, okay? So it's going to be c away from the vertex, basically. And it's going to lie on the major axis, okay? So let's say we had a graph here. And it looked like this. And our foci was here. And let's say, or let me have a better example, okay? And let's say even in the ellipse was here. From whatever the vertex is, the C will be that much away from the vertex, okay? And it's going to lie on the major axis, so whichever one is bigger or longer, okay? Could be the x on the x-axis or the y-axis, depending on the equation. And, oh yeah, another important thing to know is how to find the vertex, okay? So over here, let's look at this. It's y squared and x squared, so that means the vertex is going to be 0, 0, okay? But if the numerators, let's say it said, let's look at this, x minus 4 squared, and then there's a denominator, right? Plus y minus 4 squared again, okay? You look at these values, okay? So it'll be 4 comma 4, okay? Sorry. But that's how it's going to look like. And then using this, you can find the rest of the important attributes. And lastly, let's look at how to determine the length of the major and minor axis. So the minor axis okay, so we get these numbers from the denominator, and then the major axis will be the larger number times 2, and then the minor axis will be the smaller number times 2. So yeah, those are the basics.